I love math, math, math. Math can change the world. I love two-factor. I like the box method. Don't miss a Mr. Ing video. I love polynomials. Polynomials.
All right, let's determine whether the expressions are equivalent. So basically, equivalent just means, are they equal? I have this left side, 5. I'm going to rewrite the problem. And this side, I'm going to write this part. Let's work on the yellow side here. Let's see if there's anything that needs to be simplified. Okay, do I need the parentheses? No, I don't need the parentheses because there's no multiplication in front, there's no multiplication behind, and there's no exponent up there. Okay, so you can drop the parentheses. 5x plus 3 plus 3x squared minus 2. And here I'm just going to look for like terms. What are the like terms? So notice this one has no x's in it. No x's. Okay. So this is a strategy you can use. You can see that I underlined them, and if they have nothing in common, then you can just maybe put one underline here, and then see if I can find another color. This one has, okay, what's the difference between the purple and the blue? Okay, the purple has an exponent. Exponent is this small number up here on the top. Notice how this one does not have an exponent, and it's not a 0, it's actually a 1 for that one. And this one's a 2, so they're not the same. So let's just finish our problem here. And so we're trying to figure out, are these equal? So I have 3x squared, a little check mark that I did it. And what I'm doing here, I'll show you guys in a second. 5x here is positive because it's not negative in front. And then 3 minus 2 is plus 1. Now I wanted to note that they call this in descending order. What that just means is you have the exponents. Do you see that? 2, 1, and then 0. Okay, we don't need to write that, but I'm just trying to point why did the 3x squared go first. Okay, so it doesn't matter what number in front when you're writing in the order, it's just by the exponents. Okay. All right, so that's what we got. Over here on the right side, the blue, again, there is no multiplication in front or behind this, and there is no exponent, so you don't need the parentheses. Now, none of these are like terms. This one does not. This one has a power of 2 exponent, and none of these other ones have it. So I'll just color code them. Another strategy. None of these are the same. You would not say I have 3 red shirts, or you would not say I have 2 green shirts. So there's nothing to combine. So we're just going to put them in order now. Again, you can check mark that you wrote it 3x squared, and then to the power of 1 first. So plus 5x, and then plus 1. And then we just got to look at this one. Are they the same? The answer is yes. They are equivalent after. Yes, they are equivalent after simplifying. So just ask yourself, how can you simplify it, and then do that math. All right, let's see if these are equivalent. Are they the same thing? Okay. Now let's do the right side first. You can choose either side. And I want you to notice that there is no, I'm just going to write it, no plus or minus. Okay. So you are not distributing in this problem. Okay. So what we have to do here is, this is multiplication. And if it's multiplication, you got to do, your choices are FOIL, You may have learned that from another teacher. First, outside, inside, last. Or in my class, you're going to use the box. Let's use a box. Okay. Question. Why am I drawing this box? Okay. The reason I'm drawing this box is you have a binomial. 2x minus 2. 2x plus 1. Oh, we did this in factoring, but now we're just going the other direction. Instead of having the inside going to the outside, we're going from the outside to the inside. All we're doing here is just like the FOIL method, you're going to do the same thing. You're going to first multiply, and then you're going to add or combine like terms. CLT, combine like terms. So let's do that. 2x times 2x is 4x squared. The reason why you just multiply those, that gives you 4, then x times x is x squared, okay? 2x times negative 2, negative 4x. 1 times 2x is 2x, and 1 times negative 2 is negative 2. So we just multiplied, now we're going to add or combine like terms. There are no terms that are similar to the 4x squared, so let's write that, 4x squared, okay? 2x and negative 4x to triangles to show they're like terms because they both have an x. Doesn't matter what's in front. Now in front, we're going to add the numbers in front. 2 plus a negative 4. 2 minus 4 gives you negative 2x. And then this one right here is just a term by itself. That they call that a constant, so I'm going to write negative 2. Okay. So now we're going to do the same thing on the left side. And I'm going to show you guys the number one mistake, and then you can even pause it, try it, and then play with me. Is this one right here. This one always just drops down, okay? Students like to forget that one. So go ahead, multiply that one, and then go ahead and press play to see the answer. So let's go ahead and multiply this one. X minus 2. Okay, it doesn't matter where you could have done on the top, but I wrote mine on the side, and then x plus 1. The same thing we did over there. We're going to multiply first, and then we're going to add. X times x is x squared. Okay, x times 1 is 1x. It's not x plus 1. X times 2 is negative 2x. And again, I'm doing multiplication, so you can imagine there's actually, a dot there, but we don't normally write the dot. And 1 times negative 2 is negative 2. All right, let's combine like terms now. I have x squared is positive, so I'm going to write positive. Okay. Negative, now we're adding, guys. So remember, you multiply first. We did that. That's my check mark. And then number 2, we are adding. So negative 2, just think of the numbers in front. They're like terms because they both have an x, and then we're just looking at the numbers in front. Negative 2 plus 1 is negative 1x. And then you have this negative 2 here. Okay. We got to do some more work here on this side. So now, you see how I dropped down that green one, the 3x squared? Now we can see if there's any like terms here. Okay, these both have an x squared. So remember, if there's no number in front, in this case it's a 1. 1 times x squared is 1x squared. So I'm just going to add these now. Why? Because there's a plus sign. So 3 plus 1 is 4x squared. This one has no like terms because there's none of these have just an x. I don't have to write the 1 there. That's a little bit cleaner, and then minus 2. Okay? So then are these equal? Let's go through these. 4x squared, 4x squared, yes. Negative 2, negative 2, yes. Negative x, and that x right there is from my no, okay, is not the same thing as over here because this one's a negative 2x. So we can say, let's write our sentence. No, after simplifying, comma, these expressions are not equivalent. Okay? All right, let's go ahead and try this problem. D3, determine whether expressions are equivalent. I'm going to write this one over here on the left side. And we need to figure out if this is equivalent to this other side over here in yellow. I'm going to write all of that. Okay, these problems are getting a little bit larger, so I'm going to point out something. I'm going to write it up here. Is the order of operations. Order of operations. And you might have heard this before. Please excuse my dear Aunt Sally. Okay, what does this mean? We go in order in which you see the math operations. Okay, so for example, I'm going to work on this right side. I need to figure out if there's any parentheses or exponents. Which means, look, watch what I'm doing right here. I'm highlighting this in white here. That you're going to do this part first, not the negative. Okay? So let's go ahead and do that one over here. What does that mean? That means there's two of them. 2x minus 1, 2x minus 1. So we've done this before. So 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. 2x times negative 1 is negative 2x. And negative 1 times negative 1 is positive 1. Again, you multiply, then you add. So we're going to add now. And I'm going to get 4x squared minus 4x plus 1. I just added all the green inside there. Now, I'm going to do something here. I'm going to highlight this negative sign in red. That means everything in this expression is negative. Okay, so I still have all this. And let's distribute this negative now. Okay, you can think of it as changing all the math operations inside the red parentheses, or you can think of it as multiplying by negative 1. Okay, this is another way of thinking about it, so let's do that. So I get negative 4x squared, negative 1 times negative 4x gives me positive 4x, and negative 1 times a positive 1 gives me negative 1. Okay, and then I have to drop all this down here. Well, let's just go through and figure out which ones are like terms. 6x squared, negative 4x squared. This will give me a 2x squared. Remember, you just look at the numbers in front. 6 minus 4 gives you 2. Here in blue, 6x and a positive 4x gives me 6 plus 4 is 10x. The variable does not change. Okay? And then this last one I have in red, a 2 and a negative 1 gives me a positive 1. Okay. Let's go to this left side now. We gotta do the same thing. This one here represents 2 of them. Oh, it's not. Is it the same? No, it's not. I was hoping it would be the same, but it's not. So let's put them in here. 2x plus 1, 2x plus 1. Just go ahead and multiply here. So 4x squared, 2x, 1 times 2x is 2x, and 1 times 1 is 2. So again, we multiplied, and then we're going to just combine like terms. So I get 4x squared plus 4x plus 1. All of that in the white box turns out to be this. Now, I'll put in parentheses just to prove a point. This problem over here, I don't need the parentheses here, so I can just drop them. And then right here, we just distribute, and I'll get negative 2x squared plus 6x. Okay, so let's go ahead and find some like terms. 4x squared and negative 2x squared are the same because they both have an x squared, so 4 minus 2 is just 2x squared. 4x, 6x is going to be 10x, and this plus 1 here has no like term. Alright, let's take a look. 2x squared, looks good. 10x, 10x, and 1 and 1. What does that mean? Yes, they are equivalent. After simplifying. What are 2 mistakes I think students are probably going to make in this problem? What does something to the power of 2 mean? It means there's 2 of them. And then the other common mistake is you got to put it in the box. Okay. Students, the wrong way of just is they probably would have just multiplied those 2 in red, and then these 2 in yellow. And that's wrong. Use the box or foil. The second mistake I think is right here. Negative 2x and not distributing to the second term, the minus 3 there. Okay. I know it's a lot of work. Hopefully these colors are helpful to you. Good luck. Let's go. Determine whether the expressions are equivalent. Equivalent just basically means equals. I want to know, is this all equal to that? Okay, so let's kind of organize this. So I have the orange side, and on the orange side I'm going to have to do something right there. So I'll do it up here. I'm going to have to use FOIL or the box. And the reason why I'm going to have to use FOIL or the box is because I have 3x minus 1 and x plus 4. I'm going to multiply and then combine like terms. So I get 3x squared, multiply those 12x, negative 1x, and negative 4. So everything in the orange box there was this right there for the orange side. So I have 7x squared plus 1. I'm dropping the parentheses because there's no math operation or negative sign there. Okay, this one's going to be a little bit tricky, so I'm going to put a red pen here. And then we got to put everything that we just multiplied, 3x squared. I'm going to combine like terms here, so that becomes a 11x minus 4. So that represents the orange side, and we're almost done. We have to distribute the negative sign. Remember, distributing a negative sign is like multiplying by a negative 1. So 7x squared plus 1, negative 3x squared plus, whoops. Negative 1 times 11x should be a negative 11x plus 4. Remember, this is all the orange side. And then if I combine like terms, 7x squared and a negative 3x squared, I get 4x squared minus 11x. And then these are like terms, I get plus 5. Okay, so that represents all the orange side. And I need to figure out, is that going to be equivalent or equal to the pink side? On this pink side, I'm just going to have to distribute the 2x. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. And then I'm just going to have these. So this represents the pink side. I'm just going to combine like terms. X. So I have a positive 2 and a positive 2. Remember, on one side of the equation, you don't do opposites. You just add and subtract. That's it. So 2 plus 2 is 4. I have a negative 6 and a negative 5, so negative 6 minus 5 gives me a negative 11x. And then I have that plus 5. This represents the pink. Class, are these equivalent? They are equivalent. Equivalent. Okay, they're the same. So you're just going to have to do a little bit of math to kind of simplify this. Alright, D5, let's try it. The sign 6x times x plus 1. And is this going to be equal to the right side 6x squared plus 6? Okay. Alright, the first thing I notice in this problem is a set of parentheses. And something I notice is, what is the math operation here? It is multiplication. So you have to distribute. Distribute means to multiply. So we're in COVID, and the Los Angeles County or Southern California, they just canceled Halloween, right? So, but if you were, like, it would not be fair if you kind of just pass out candy to certain kids or certain costumes, and then you do it to others, right? So you got to distribute to each of those, right? So 6x times the x, and this is the 1 here. So you're going to get a 6x squared. 6x times 1 is 6x, and the 6x here is positive, okay? Let's go over here and see what happens, okay? You cannot add these, okay? If you, you can say I have 6 Reeboks and 6 Jordans, and I have makes 12 Jordan shoes, okay? They're not like terms. It's like Reeboks and Jordans are different. You can't add those. So I just have this right here. And then use some check marks to kind of go through. Well, I have a 6x squared, but this one is 6x. Do you see that? And this one's a 6. So I'll just write the word no. No. What? The expressions are not equivalent after simplifying. That was D5. All right, D6. Determine whether the expressions are equivalent. Let's work on this left side over here. Rewrite it. So I have plenty of space. And again, we're trying to figure out if they are equivalent. It's a question. 8x times 3x plus 1. Let's do the easy side. The right side, yellow here. Remember, we are essentially distributing here. This is going to be multiplied to each of these terms. So 8x times the 3x, and then the 8x times the 1. So what do we get? We get 24x squared, because remember, x squared is just x times x, which you have right there and there. 8x times 1 is just 8x, and remember 8x is positive. That's why I'm writing a plus sign there. Okay, and that's it. Those are not like terms. You cannot add them. Do not add 24 plus 8. That does not equal 32x squared. That does not equal 32x cubed. It's just like that. All right, let's look over here. Let's see what we got to do. I have that 8x, and I'm going to again distribute to each of those terms. Why am I distributing? Because that means multiplying. How do I know to multiply? There is no plus or minus right there. And it is implied when they are next to each other to multiplication, like a dot. Dot, see? Okay, let's multiply. So I have 8x, 8x. So 8x times the 2x. Right here. And then the 8x times the 1. So let's simplify that. Now, I'm going to drop down something here because a lot of students forget stuff like this, okay? That's where we go line by line. Super helpful. 8x times 2x is 16x squared. 8x times 1 is 8x, and it's positive. That's why I wrote a plus 1, and I have 8x squared here. Well, I got to do something here. I have like terms here. Do you see how they both have an x squared? So now I'm just going to focus on the number in front. 16 plus 8 gives me 24x squared. And this one has no other terms that have just an x. All right, let's take a look. 8x, 24x squared, 24x squared, positive 8x, positive ax. Yes! The expressions are the same. What's the word for another same? Equivalent. After simplifying. I'll give you a real life example and then this should make sense to you. Yes, the expressions are equivalent after simplifying. These questions are basically kind of asking, right, like think about money. You guys all like money. It's kind of like, is 4 quarters equal to $1? Is 4 quarters equal to 10 dimes? Is 10 dimes equal to 100 pennies? Does that make sense? They're just asking, are they the same? And so we just apply our math operations to that. So that's it. That's D6.
If you love my pretty money, let's begin to try it with me, and you will get the score. Better, better, better score, and then try again with me. Let's begin again right now. Again.